Hey everyone, welcome to Maximo Visual Inspection Tech Sales Level 3 demo. In this demo, we are going to take a use case of a water resource authority that needs to manage its assets that are spread across multiple cities and regions. And in order to maintain water quality standards, they need to make sure that all the water sedimentation tanks are free from any fungi or unwanted debris. And as you can imagine, in the absence of an automated and scalable solution, such a task is very human resource intensive. So, as an asset analyst, you have been tasked to develop a computer vision AI model that can replace the need of frequent human inspections. So in this demo, we are going to look at things in four main parts. In the first part, we are going to assume that the asset analyst solution is now in production, and we will observe how the algorithm or the AI model sent inspection alerts using an application called Maximo Monitor. And in the second part, we are going to look at exactly how the computer vision model was built step by step using Maximo Visual Inspection. In the third and fourth part, we will see how the AI model will be used to perform inspections in MVI Mobile and MVI Edge application. Let's begin with the first part of our demo. We would first need to log in to IBM Maximo application suite using the provided login credentials. As soon as you log in, you will land at this suite navigator, and different applications that make up the overall application suite can be seen here. For this part, we are going to click on the monitor application. Let's click on monitor tile once again. On this screen, we can see a list of device types for this water resource authority and whether any analysis is on or off for the device type. Since today we are interested in water sedimentation tanks, so I would use this search bar to filter the results for sedimentation tanks. Once the result is filtered, we are going to click on the result to navigate to the sedimentation tank dashboard. This is tank specific dashboard screen. Here in the tank inspection results tile, we can clearly see different inspections that were performed by our AI model. We can see when the inspection was performed, what was the outcome of that inspection, and what was the device ID of the corresponding tank. Here we can clearly see that tank number 2 most recently caused a dirty tank alert at around 5:43 p.m. on 16th of May. If we scroll further down on this screen, we can also view a global map of our sedimentation tank assets. Any tank that passes a given threshold will cause an alert, and that alert can be seen right here in the map. At any point in time, the plant manager can visually confirm the results of the AI model by the results. They would simply click on this link under device ID column which says tank 2. Once clicking on this link, they can confirm that indeed one of the tanks is dirty and something needs to be done. After visual confirmation, they can scroll down and assign an owner for this dirty tank alert to take care of the issue. This concludes the first part of our demo process, in which we looked at how Asset Analyst's AI model solution can send inspection alerts to the monitor dashboard, where Plant Manager can visually confirm the inspection results and can also assign owners to take care of the issue. In the next section, we are going to look at how exactly this computer vision AI model can be built using IBM Maximo Visual Inspection application. For that, we are going to click on top left where it says IBM Maximo Application Suite to navigate back to the suite navigator. Once the suite navigator is launched, this time we are going to click on Visual Inspection tile. Now we have entered in IBM Maximo Visual Inspection application. Next, we are going to click on Get Started blue button. As a first step towards building the AI model, the asset analyst must create a dataset in MVI containing images of clean and dirty water sedimentation tanks. In fact, data is at the heart of machine learning. In case of vision-based models, this data is in the form of images or videos. Built-in MVI models can intelligently detect and learn patterns in the uploaded data, and they keep on analyzing the data until and unless it starts to learn and recognize the objects of interest in the images. For example, if today we were building a model to detect faulty automobile tires, we would need to upload lots of images of correct and faulty tires both, so that the models start learning what creates a distinction between a good tire and a bad tire. We are going to use a limited number of segmentation tank images, but in practical scenarios, you would need many more images and more computing time than this lab offers. To begin the process of creating dataset, we are going to click on the blue plus icon right here. Once clicked, a pop-up window will appear. Here we have to choose the name of our dataset. For the name, we are going to write segmentation tanks. Once we have written the name segmentation tanks, we are going to click on create. This will introduce a new tile in the main datasets page. Next, we are going to click on the lower half of this newly created segmentation tanks tile. The segmentation tanks dataset screen is ready for us to perform key operations such as uploading images, labeling objects in the images, augmenting data, and training our model, as we will see in the upcoming steps. To start the process of importing the images, we are going to click on Import Files. The File Navigator window opens, and from here, we are going to use the images that are provided in this lab script. We are going to select all the images and click Open. After a few seconds, all the images are uploaded. Now these images are ready for labeling. Labeling is tagging the input images with information about its content, and in the case of object detection, this would also involve highlighting the occurrences of items of interest. For example, in an image of water segmentation tanks, you would have tank but also background around that. So we would need to highlight the portion of the image that represents tank. And during the training phase of the model, these labeled images will allow our model to learn which part of the image represents a tank, and next whether that image portion contains a clean or a dirty tank. And as you can imagine, labeling the image correctly is particularly important as it directly impacts the overall quality of the built model. And quite simply, when it comes to identifying objects or classifying images, you would want the domain expert to do the labeling, to ensure that the highest quality of input is provided during the model training phase. But traditionally, data scientists has been the focal point of AI initiatives because the technical barrier to entry was quite high. But with MVI, a SME with limited to no data science experience can easily drag and drop and do image labeling for the AI model. In order to start the process of labeling these images, we are going to first select all the images by clicking on this checkbox. This will select all the images in our dataset. Next, we are going to click on Label Objects button. On this page, we can create labels for clean and dirty tanks and assign them to the relevant portion of the images. But first, we should define the labels. In order to define labels, we are going to click on the top right, Add Label. The Add Objects screen pops up. Here, first we are going to write clean because there will be two labels that we are going to use, one for clean segmentation tanks and the other one for dirty segmentation tanks. Once you write clean, we are going to click on Add. Next, we are going to write dirty. Click Add. Once both these labels are created, we can click OK. Okay. Once both labels are successfully created, you would see them on the top right section under Objects. Now we can start the process of labeling the images. As we can see in the image navigator on the left, that the first image is selected, which represents a clean segmentation tank. Hence, among these two labels, we are going to click on the clean label. Next, we will use the box icon to draw or to highlight the clean tank portion of the image. We have successfully labeled the first image. We are going to repeat the same process to label all the images. Of course, if you see a dirty tank, instead of clean, we are going to click on the dirty label, once again on the box icon, and create a box around the image portion that represents a dirty tank. Repeat this process to label all the images in the image navigator. Once all the images are successfully labeled, we can hit the back icon to go back to the dataset page. Even at this point, we are ready to start training the model. But generally, the more images you add to the dataset, the higher the accuracy of the model is likely to be. And in practical scenarios, we would use many more images than we are using right now in this lab. Also, it's fair to think that a field camera is not going to take images of the tanks under the same conditions all the time. Lighting can vary depending on the weather and time of day. Similarly, if the camera is rotatable, then its focus and orientation to the tank can also be inconsistent. And rather than trying to provide images to cover all these possible scenarios, MVI addresses this pain point by providing image augmentation features. In image augmentations, filters can be applied to perform operations such as flipping images, sharpening them, blurring them, or cropping them to create additional images, thus increasing model performance and decreasing the cost to acquire more data. The image augmentation process multiplies the original number of images by several folds, and the good news is that you do not have to relabel those additional images because the labels of the original images are transferred to the augmented images to avoid the rework. To start the augmentation process for these images, we are going to press this Augment Data label. Here we are provided with different options available for us to augment the images. We are going to choose a few of these options. After choosing the options we want to apply to our images, we are going to press Continue. At this point, Augment Data pop-up window will appear, and we are required to write the name of the new augmented dataset. Let us give the name of this new dataset Augmented Segmentation Tanks, and let's press Create Dataset. A message will shortly appear that the augmentation process has started. Once the process is completed, in order to view your newly created augmented dataset, we would hit this back icon once again to go to the main datasets page. Over here, we can see both our datasets, the original segmentation tanks dataset and the augmented segmentation tanks. You can clearly see the increased number of images from 13 items to 234 items. Let's click on the lower half of the augmented segmentation tank style. Here we can see that several images have been newly created after the augmentation operation. All the images that have been formed due to augmentation operation do have this little black star icon at the bottom right. Here you can also see that labels are inherited from the original images to these augmented images. With these increased number of images, now we can go ahead and start the process of training our AI model. In order to start the process of training the model, we are going to hit this blue Train Model icon from the Augmented Segmentation Tank image dataset page. On the model screen, we have to select the kind of training we want our model to do, and secondly, which model are we using. For our demo, we are going to use object detection and faster RCNN model in the optimized model section. Based on different scenarios, you can choose different type of training and models. Since in our demo use case, we are building a model which would be required to identify the tank from the image of the camera feed. Hence, we are going to go with object detection and faster RCNN model because it is optimized for higher accuracy. On the screen, we can also click on this advanced settings switch and set it to on. Once it's set to on, model hyperparameters are visible. Hyperparameters are the values that are used to increase the performance of the model. When it comes to increasing the accuracy of the model, hyperparameters are the go-to metrics for data scientists and other model experts. Here you have several options. For example, choosing the number of iterations data is going to pass through the training algorithm, how much data do we want to dedicate for training and how much for testing, etc. For the purpose of this demo, we can leave the hyperparameters to their default values. Now let's scroll back and press train model to start the training process. During the computer vision model training, pixel level information from the image dataset is fed into the training algorithm, where a convolution neural network helps the algorithm look by breaking the images using their labels. It also checks its accuracies during these predictions until the predictions start to come true, pretty much similar to how a human biological neural network works. In fact, that's how the name came out to be convolution neural network. And the good news is Maximo Visual Inspection simplifies and streamlines this model training process through automation and no-code solution, as you are seeing right now, thus putting deep learning into the hands of empowered subject matter experts. Since the training here is going to take around 30 minutes, and in fact a practical model would require many more images and computation power than what we are using right now, let us show you the next steps of model testing using a pre-built model that has been built using 2000 plus images of segmentation tanks and several hours of computation. To move forward with the pre-built model, we are going to click on this hamburger icon, and from the list that appears, we are going to click on deployed models. Let's click on this hamburger icon once again so that the list goes away. On this screen, you will see a list of pre-deployed models. From here, we are going to click on the augmented segmentation tanks _ model. This is the model that has been pre-built, and we are going to do model testing and validation using this model. In order to move forward with the testing phase, let's click on the name of this model under the name column. On the deployed model screen, we can view once again the model hyperparameters it was trained under, the accuracy of the model, the API endpoint of the model, and under test model tile, we can import an image of segmentation tank, and the model can perform its analysis and give out its inference results. Let's click on the import button in order to import a test image so that we can view the performance of the model. Okay. Once again, we are not using any of the images that were already used for model training. Instead, we are going to use images from the validation folder that has already been provided in the lab script. This is a pretty standard practice in building ML models, and the idea is whatever model we have built with the training images should be generalizable enough that it can accurately infer the results from the images that were not taken into consideration when training was performed. Okay, so we are going to select one image from the dirty tanks folder, any of it, doesn't matter. Let's select the first one and see if the model does infer this tank image as one from the dirty tank. Okay, as we can see right away, model performed its calculations and deemed this image to be of a dirty tank, as we can see right here with high confidence. We can once again repeat this procedure, and instead this time we are going to use image of a clean tank. Okay, again, any of it doesn't matter. So let's select this image. Okay. Now the model once again ran the calculations and found this image of a cleaned tank. After visual confirmation, the plant manager or the asset analyst can validate that their model is working correctly. They can repeat this procedure more times before they are confident enough to start the deployment. And with a validated model, we can build a dashboard in Maximo Monitor that will display the result of the tank inspections from live feeds, as we have already seen in part 1 of this demo. Now that the asset analyst has trained and validated the AI model that can detect clean or dirty segmentation tanks, it is time to use the AI model to perform automated visual inspections. These inspections can be performed in MVI solution using either MVI Edge or MVI mobile application. In this part of the demo, we are going to use MVI Edge to configure inspections. MVI Edge is a web-based application that enables AI inspections on the edge. By edge computing, we mean the computing that takes place at or near the location of the user or source of the data. This proximity saves valuable processing time by removing latency issues. To continue with MVI Edge, first we need to log in to the Edge server. Once logged in, we will land on the main dashboard screen. On this screen, you can have a quick view on all the inspections that are currently enabled or disabled for your organization. Each of these inspections are tied to certain stations. You can think of stations as separate entities within an organization. For example, if multiple segmentation tanks, let's say 3 or 4 segmentation tanks, are in one location, then we can assign all those 4 tanks under one station. In each of the stations, you can have multiple inspections running simultaneously. And on this dashboard, as you can see, you can have a quick view on the total number of automated inspections that have been performed and the number of passed or failed inspections. Since this is a demo environment, inspections and stations have already been created for us to save time, but if today we were creating an inspection of our own, then we would have selected the options from the left of the side panel. On this left side panel, you have options to create your own stations, check out different models that you have trained on MVI training server, and also select input sources. The Edge server allows image or video input sources or an live feed from RTSP camera as well. In addition, the power of MVI Edge can be really enhanced when you can connect it with certain other external applications. For example, within the settings menu, we can see that you can connect the Edge server with MQTT or Twilio. Using both of these applications, any inspections that have been performed can be quickly used to send out alert notifications in other applications, for example, Maximo Monitor or even on your mobile phone device. Lastly, at the bottom, you can see a green check mark that tells you that the Edge server is connected to Visual Inspection Training Server, which means any AI models that you would have trained over there can be easily used right in this Edge server environment. Let's continue with the demo. Now we are going to click on Segmentation Tank 2 Inspection under Inspection column. Recall the tank number 2 was triggering alerts in the first part of the demo. When we click on this inspection, we will land on Segmentation Tank 2 Inspection main screen. On this screen, you have basically 2 tabs, the Images tab and the Configuration tab. We'll come to the Images tab later on. For now, let's skip to the Configuration tab. In the Configuration tab, everything that you need to know or configure about an inspection is available right here. You have different options to select whether any images taken as part of the inspection should simply be collected for training an AI model at a later stage, or you want to perform inferences on those images. Secondly, any projects, models, and datasets that you have created in the MVI training server are available for you. For this demo, these options have already been selected for us, so we will skip changing any of the menu options here. Next, we have the rules section. This is one of the main areas of this screen because here you can configure different rules that will constitute whether an inspection is pass or fail depending on results of the AI model. Let's click on this gear icon under settings for a failed inspection or a dirty tank inspection. Once you click on the gear icon, rule settings screen pops up. On this screen, basically, you're telling the edge server that if the results of the AI model come back with a confidence score of more than 0.5 or 50%, that this image is of a dirty tank, then deem the inspection as fail. Next, within the same pop-up screen, you also have an option to decide what happens once an inspection has failed. Either you can connect the edge server with MQTT, which enables the edge server to talk to other applications like Maximo Monitor, or Twilio application. Using Twilio, results of an inspection can be sent quickly to any phone number via SMS services. To use this feature, let's select the Twilio option. Here, we will write a phone number where we would like to get the SMS inspection results. Now, we are ready to hit save. We can repeat the same procedure for a clean tank. But this time, we are telling the edge server if the AI model is more than 50% sure that the image belongs to a clean tank, then we would categorize the inspection as pass. And again, depending on whether you would or you wouldn't like alerts for a pass inspection, you can choose the appropriate action right here. I'm going to select Twilio again and enter the phone number where we would like to receive the SMS alerts and the corresponding alert message. Next, we are going to click Save. We have successfully configured the rules for our inspection. Next, we will select the input source for our inspection. In a real-life scenario, this would be a live camera feed. But for the purposes of the demo, we have selected an image folder that contains images of several segmentation tanks in different conditions. So you have tanks in clean state or dirty state. Basically here we are performing a batch processing of all these different images and asking our model to perform inferences on each of the image and come back with the results. But because this is a shared demo environment, we want to quickly check whether these images are not being processed already. So for that, we are just going to quickly click on Edit Input Source and scroll down. See how these images have been processed already. So we will click Reset so that these images move back to the unprocessed state and now are ready again for the inspection. Let's click Save. Now we are ready to perform inspections. Let's click on Enable Inspection blue button to start the inspection process. Once the inspection is enabled, if you scroll up, you will see the status of the inspection has changed to enabled. Now we can go to the Images tab where results of the inspection will be shown to us. Here we can see all the images that were in our image input folder, and each image contains certain icons. These icons serve as a quick way for us to know the results of our inspection. For example, the green check mark here tells that the state of the segmentation tank is clean, hence the inspection has passed. Conversely, if you see a red cross mark, that means the inspection failed because the AI model is more than 50% sure that this image belongs to a dirty tank, as we can also visually confirm. Clicking on any of these images can show us more information about the inspection. For example, let's click the first image. Here, you can see that the AI model is more than 96% sure that the image belongs to a dirty tank, hence the inspection has failed. And for each of the inspection, you can see an exclamation mark in a triangle that indicates that an alert has been sent out about the results of the inspection. If you remember, because we have configured the edge environment with alert settings, hence an alert has been sent about the inspection. This concludes the MVI edge inspection portion of the demo. We saw how different rules can be configured within an inspection to determine whether it is pass or fail. We can also set different alert notifications using external applications like MQTT or Twilio on the MVI edge. In the final part of the demo, we are going to use the AI Model Asset Analyst build to create and configure inspections in MVI mobile application. But first, we need a way to connect MVI training server where we have trained the model and MVI mobile application on our iOS mobile device. This can be done using a QR code or an API key. In order to get the right QR code from within the MVI training server, we will hover over the left side panel and click on Services. A submenu opens. Then we are going to click on the API key to reveal the QR code. Now we have the QR code that will be scanned by our MVI mobile application in order to integrate with the MVI training server. Now we will move to the mobile application. Now let us see how a model trained on MVI training server can be used to perform inspections using IBM Maximo Visual Inspection mobile application. MVI Mobile is a native iOS or iPad mobile device that runs on Apple devices such as iPhone and an iPad. This provides a very low barrier to entry in terms of hardware costs and time to value. The sophisticated optics on Apple devices are combined with the ability to run models generated from the MVI core application. Like rest of the applications in the MVI solution, MVI Mobile also delivers agility with point-and-click ease, but only through a footprint of a mobile app. In a matter of hours, clients can train complex computer vision models on the core MVI platform and then deploy the trained models to the MVI mobile device to perform inferencing. Let's click on IBM mobile application. Here, you will land on the global settings screen. On this screen, you have several options to configure the mobile application environment. First, we are going to select the handheld mode here. MVI mobile application has flexibility to be configured by either a handheld mode or a fixed position or demo mode. In the demo or fixed position mode, as the name tells us, it is expected that the mobile device is going to be fixed in one position, such as an assembly line, and from that fixed position, device is going to take pictures and perform inferencing. But in the handheld mode, it is expected that the device will be carried. For example, a quality inspector can easily carry the mobile device to an inspection site and harness the power of AI models to detect any anomalies by simply clicking a picture of the inspected part. These options result in a dramatic improvement in production quality inspection. Let us continue the use case of water segmentation tanks and see how inspections can be created and configured in the MVI mobile application. For that, once we have selected the handheld mode, the next thing is to integrate the mobile application with MVI training server. We can do that using a QR code. The QR code will be displayed on the MVI training server. From the mobile application, we are going to select Scan QR code option. This will turn on the device camera. The camera is now ready to read the QR code. Once the QR code is successfully scanned, both the applications will be integrated. Next, it's now time to create new inspections. In order to create the new inspection, we are going to click on the blue icon on the top part of the screen. This will open up Create New Inspections pop-up screen. We'll quickly name our new inspection. Next, we are going to select Project, Model, and Dataset from the drop-down menu options. The drop-down menu options are directly coming from MVI training server. So any model, project or dataset created over there will be available to us right here. Once the project is selected, next we are going to select the AI model that has been trained. On the model pop-up screen, it's time to set thresholds. Thresholds are the values that once passed by the confidence score of the AI model will dictate whether an inspection is a pass or fail. For example, in our case, we have two conditions. Either the sedimentation tank would be dirty or clean. We are going to click on Set Thresholds. Both the possible labels in our scenario, such as clean or dirty, are available to us. In order to set thresholds, we are going to click Advanced under the dirty label. For the threshold value of dirty label, we are going to write 50%. This means if the AI model is more than 50% sure that this is a dirty tank, then we will classify this inspection as failed. Once we selected the threshold value, next we are going to click on Set Threshold option to go back to the previous screen. We are going to click Advanced under Clean this time, but because we do not want to perform any further actions if the tank health is detected clean, hence we are going to select No Option toggle for the clean label. Once again, we will click on Set Thresholds to go back to the previous screen. Next, we are going to click Model to go back once again. Finally, back one more time. Once project model and dataset have been selected, we are going to click Done. Our new inspection has now been created. You can view your inspection in a list format on the left side of the screen. If you had multiple inspections, they all would appear here. And in order to view more information about any inspection, we would simply click on it and the information would be available on the right side of the screen. Although now we are good to start our inspection, but there is one more thing we are going to do, and that is to attach this inspection with Twilio application. This will help us get SMS alerts once an inspection has been performed. You can imagine the utility for this feature. The concerned person does not have to be always in front of their monitor screen to know about what's going on with the inspection. We can configure it as such that whenever tank's health is detected dirty or an inspection is failed, in other words, the concerned person is going to get SMS alert right away. To integrate Twilio application here, we are going to click on the blue gear and phone icon. This will open up the configure device page. Here we are going to click Twilio settings, and on the Twilio settings screen, we are going to enter the information from our Twilio account. Once the information is entered, we are going to click Save. Now we are ready to perform inspections. To start inspection, we simply need to click Capture. Once clicked, this will turn on camera of the mobile device. Once we take picture of the tank, the AI model will run inference on it and will predict whether the tank's condition is clean or dirty. In addition to looking at individual inspection results, we can also have a holistic view of the total number of inspections by using MVI Mobile Dashboard option. Let's click on Dashboard from the main inspection screen. Once on the dashboard screen, here we would first need to select our project using the blue circle with ellipsis icon. Once we click on it, we would need to select the right project and also the dataset. Once both these options are selected, you will see the total number of inspections that have been performed on sedimentation tanks along with pass and failure rate. This concludes the demo. We observed how the MVI AI model sends inspection alerts to Maximo Monitor. We also performed the steps to build a computer vision model and use that model to configure inspections in both MVI Edge and in MVI Mobile. Lastly, we can think of this comprehensive solution where an AI computer vision model sends critical alerts beyond the use case of sedimentation tanks and apply it in any mission critical areas where it is essential to visually detect objects of interest repeatedly at a fast pace and scale. For example, fast-paced product lines, transmission lines, and other quality assurance settings. Thank you for listening.